This is the Earth Science Classroom. Welcome back to the channel. In this video, we're looking at what a banded iron formation is, a BIF, in geology, and it's a certain topic that covers geology, economic, minerals, essential minerals that we extract from the Earth, and a certain time in the Earth's history when this rock formation formed in a very special or unique way. On Earth, we've got certain minerals or natural occurring materials that are essential for our society, for business, for commerce, for trade. And one of those mineral commodities, or essential minerals as they're known by, is iron ore, and how we process iron ore to create tons of different materials, products, and helps to maintain our world economy. Not just in the US or Europe or Asia, but in general, the whole planet. And we find iron ore in certain minerals and certain rock formations. So if you can find a particular rock formation that has a large percentage of either hematite or magnetite present, you can extract this and take out the iron ore and use it for processing and sell it and make money. So certain parts of the world have a large depository amount of this hematite and magnetite in certain rock formations. So economic geology is a big deal. Now, these banded iron formations occur in certain locations, but they occur, or they formed through a certain process about 3.8 billion years ago up to around 1.8 billion years ago. And this covers both the Archean and Proterozoic eons, covers a large expanse of time, and they formed through a certain process. So the name kind of gives it away, banded iron formations. It's basically bands or thin strata that range from 150 to 600 kilometers deep and varies in width and size, but they are basically thin bands or strata or layered iron-rich hematite or magnetite or even pyrite. And in between these layers of iron-rich rock or sedimentary rock, you have layers of a quartz or silicate, chert layer, depends on the type of the BIF. But you get these layers, like a big layer cake, basically. And these certain layers are formed in a certain process. Now, about 3.8 billion years ago to 1.8 billion years ago, and the span of time between that, you had a very different planet in terms of the atmospheric composition, the ocean's composition of the chemistry, and volcanic activity, hydrothermal vents, mid-ocean ridge rifting, and tectonics or basic tectonics, and how all of the combination of the effusive emission gases from the ocean floor, plus the atmospheric composition, plus the weather and erosion of silicates and sulfides from the continents or the early continents into the primordial oceans, and how the combination and melting point or melting pot of the oceans kind of created this unique sedimentary structure that we find in the crust today. So the process to form this rock formation is the emergence of single-celled organisms, microbes called cyanobacteria. And these little microbes lived in the ancient oceans, and they started to produce oxygen as a byproduct. And oxygen started to slowly seep into the oceans and up into the atmosphere, and started to increase the percentage of oxygen in the atmosphere. This then also dissolved back into the oceans, and the oceans started to chemically react with this oxygen. And the iron 2+ and iron 3+, the iron basically formed iron oxides, which then precipitated and deposited on the ocean floor as these bands of sedimentary rock that was hematite and magnetite that was inside these rock formations. And the banded layer nature comes from the superposition and the nature of how sedimentary rock is deposited and accumulated over time. And this process of chemical reactions in the ocean occurred for over 2 billion years. And during that span of time, it happened in different stages based on the amount of oxygen and also the amount of other reactions happening inside the oceans, because it's not just the oxygen that combines. You can also create hematite, malachite through other means without the necessary requirement of oxygen or a high level of oxygen. So in conclusion, a BIF, or a banded iron formation, is what it really is. It's a bunch of layered, deposited sedimentary rocks that are highly concentrated in iron, and they're found around the planet, and they were formed through ancient ocean chemical reactions on the ocean floor, and how oxygen kind of combined with iron and created this large amount of deposited iron-rich sedimentary rock that we now use today as for iron ore. And it happened at a certain time in geologic history, and it's kind of unique and shows a lot of different changes that happened in that time based on how these iron-rich rocks are formed and also where they occur. Thank you so much for watching the video. I hope you enjoyed it. If you like it, please subscribe and maybe hit the like button. If you like more on this content, please check out my channel, which has all these videos on Earth science.